Institute of Technology, a constituent college of Vinaya Missions Research Foundation, deemed to be university, is very much delighted in organizing the virtual workshop on machine learning and deep learning and their use cases. I'm very much confident that this virtual workshop will help in acquiring ample knowledge at the end of the session. With this note, now I request Dr. L.K. Hema ma'am, Professor and Head ECE AVIT to deliver welcome address.
Thank you, Vanita. So, good morning to one and all joined here for this virtual workshop on machine learning and deep learning and their application in various domains. So, it is my privilege to invite you all to this workshop on machine learning and deep learning, which is to be presented by Mr. Shabarinath Premlal, founder and CEO of Respro Labs. So, thought of conducting through virtual platform to give an overview of all the applications of machine learning and deep learning in various domains. So as for AICTE, this is one of the thrust areas which is focused by AICTE to undergo by the students and faculty fraternity. They have to upgrade their knowledge in the field of machine learning and deep learning, which can be applied in various applications, starting from electronics and healthcare application, automotive industry, then entertainment, then this artificial intelligence, machine learning, and deep learning is playing a vital role. So, to discuss about all the application areas, Shabarinath Premlal sir, who is going to highlight the importance of the topic we have chosen today. And on the behalf of our management, Arubadevidi Institute of Technology, Vinayaka Missions Research Foundation, Department of Electronics and Communication, it is my privilege to welcome you, sir, for this webinar virtual workshop session. And it is my privilege again to invite our beloved Vice Principal, Part-Time Studies and Professor of Electronics and Communication Engineering Department, Dr. Vijayendra Babu, sir, who is the back force in all our events which we are conducting in our department. He is rendering wonderful support in the technical and academic perspective. On behalf of department and faculty and student fraternity, I welcome you, sir, for this program. And next, I extend my welcome to all the student participants from host institution and from the faculty from other institutions also joined in this event. I welcome you all to this program. Next, I welcome all the faculty of our department and others who have joined in this webinar. So, be online throughout the program and gain the input what Mr. Shabarinath is going to share with us. So once again, I welcome you all on behalf of EC department. Thank you.
Thank you, ma'am. Now, I'm glad to invite Dr. D. Vijayendra Babu, sir, Vice Principal, Part-Time Studies and Professor of ECE Department AVIT to deliver special address.
Thank you, Vanita madam. Thanks, Dr. Hema madam, for your kind words. Am I audible, madam?
Yes, sir.
Yes. Good morning to all of you. It's a wonderful event today. Sri Shabarinath Premlal, founder, CEO, Respro Labs, Chennai, Tamil Nadu, is going to address our students on machine learning and deep learning techniques and their use cases. Welcome, Sabari sir. I hope we have been connected for the last 4 years and much time it was not able to collaborate. I hope from this session we can able to collaborate and get into more active collaboration like projects and student engagements too. And we expect your contributions to us in all domains. I sincerely appreciate the initiative taken by Dr. Hema Madam, HODEC, and all the department faculty coordinators, Mona Priya, Vanitha, and the entire team of EC department for initiating such a wonderful topic of current scenario. Warm welcome to all the students and all the participants from various departments and participants from other institutions too. As this is one of the significant topic of current day of scenario, machine learning, deep learning, and artificial intelligence. Now its more focus is on machine learning. It's a very huge market is also exploring on it. And with respect to huge investment for beyond 2020, I just gone through article which about speaks about machine learning applications starting from application oriented different platforms, smart robots, computer vision platforms, natural language processing. It's all goes on. So not only with respect to academic points of view, but in future aspects also, we are going to live along with this machine learning techniques or artificial intelligence application. Like his topic is also concentrates on use cases. So it's wonderfully is not going to talk about the theoretical parts or application oriented. It's going to demonstrate its few use cases as it's not restricted to single domain. As you all know that it is in a collaborative domain. Now it all is going to holistic approach. So either from automotive, it is going to be in driver safety system, or in financial services, it may be on authentication on portfolio management, or in terms of healthcare, it's about disease prevention and diagnosis, or in tech media, telecom, about network security or personal assistant, or in retail sector or industrial sector, smart building, even on education field, most even exam conduction. These algorithms plays a major role in current scenario, not taking much of the time. I wish the entire program to be successful, and I request the students, the participants to exploit the situations well. Thanks for the opportunity given. All the very best. Thank you.
Thank you, sir, for your words. Now I invite Mrs. R. Mohanapriya, Assistant Professor of ECE, to introduce the resource person of the day, Sri Sabarinath Premlal, Founder, CEO, Respo Labs. Mohanapriya ma'am, you are not audible.
Hello. Madam is not audible. Mohanapriya madam, right?
Yes, ma'am. Yes, ma'am. Mohanapriya ma'am, your voice is not audible. Not audible, ma'am. Kindly check the connectivity. Mohanapriya ma'am, check your mic, ma'am. I think something is wrong with your mic. So please check that.
She is having some connectivity problem. She
Yes,
is
sir.
again
Yes,
joining.
Yes, ma'am.
He is joining.
Not audible, ma'am. A few minutes, we're trying to fix the technical issues. I request everyone to hold on for a few moments.
Vanita, madam is having some technical issue in joining through audio. Let me share the profile
Yes,
of
ma'am. Profile of chief
yes,
guest,
I'll
Sri Sabarinath Premlal.
yes. Let me introduce him.
Thank you, ma'am. Thank you.
So it is again my privilege to introduce today's guest, Sabarinath Premlal sir. He is an embedded engineering graduate having a decade experience in embedded hardware, board design, IoT, artificial intelligence, AR/VR solutions. Served in leadership positions for automation projects with several industry and institutions. Experienced visioning, casting, and executing projects from inception to launch, and is able to provide a structured framework to analyze complex situations into simple strategic imperatives. He is an embedded engineering graduate with an experience in the domain, as I mentioned, in various technology. He worked in IT-based industries like TCS, FL Smith, Intel, etc. He is a certified parallel programming and optimization of Intel architecture for Intel Xeon processor. He is also certified in AAE, ARM accredited engineering for ARM Cortex AR and A&R processor. He is also versatile in IoT platform, AR, VR, and blockchain. He has participated and won in Intel IoT Roadshow, winner in FTF 2014, Freescale Robert Bosch Hackathon, ARM SoC Design, Smart City Hackathon, Atmel Hackathon, etc. He also published books on signals and systems, embedded system with IoT. He has organized more than 130 plus workshop and FDP in different colleges and industry. He has presented more than 160 plus guest lectures in different platforms. He is also a founder in Respro Labs, Educhrome Educational Trust, Shah's Publication, and CHET. And his current solution consulting industry is in the domain of implementing IoT-based customer engagement platform with current technologies, including machine learning algorithm and natural language processing, created an analytics framework based on customer satisfaction. He is also a senior business consultant, product management at Standard Acoustic Engineering. And he managed a team of strategic new product development and rollout systems of Oracle Corporation. He is the key person to develop business and initiative rollout for Right Now Service Cloud, Fusion Sales, Cloud Eloqua Marketing, Cloud into the existing portfolio of Oracle CRM on demand. So he is having wide knowledge in the area of machine learning and deep learning, embedded as well as IoT platforms. So he is going to give more insights about the various applications of machine learning and deep learning in the real-time scenario. I welcome you, sir. Now the platform is yours.
Madam, and I'd like to thank the management and the professor Vijayendra Babu, okay, Mohan Priya madam and Emma madam and the people who are all connected. I mean, especially the participants. Okay, so I'll be delivering about the machine learning in detail and also in deep learning also. Okay, so how we can able to kickstart it? So what are the platform which is available? Okay, what are the things that we can able to infer from that? So these things I will be explaining today. Okay, before kickstarting with the actual session, better I just give a demo at the initial stage itself. Then I will be connecting you with different concepts of what is ML, what is DL. So the first I will be sharing my screen. Yeah, I think you can able to see my screen. Okay. So here you can able to see a link. So this is a generic link which is available. Okay. So even I will share this link also. Yeah. Sorry. Yeah, I shared the link. Okay. Even you can able to verify in the chat. Okay. So here I'm going to connect without programming anything. I'm going to add the real-time image. Based on the real-time image, I'm going to do the classification algorithm. So right now I'm having some development boards. So I'm going to connect, which is based on this development board. Okay. So here I'm just changing the development board as Azure. So here I think the camera is visible to all. Okay, so this is the development board. I'm going to take some sample image of this one. Okay, so here I'm taking some sample images. So I took around 100 images approximately. So this is the sample image of this particular board. This is from the ABNet, especially for the Azure Sphere. Okay, so then I'm going to connect with another class. Okay, I'm naming it as a free scale. So I'm connecting with the output N0 plus processor. I mean controller. So here also I'm taking around 100 plus images. So approximately 130 images. Then I'm going to connect with another board. So I'll be adding at least 5-6 boards. So I took the images of the Renesas board also, then MediaTek processor, so I took 100 plus images and the generic one, the Arduino. So I'm going to take samples of the Arduino board also. So I took around 80 images. So finally I'm taking the Raspberry Pi board. Okay, so I took 100 plus images. So totally I'm having around 6 different classes. So I'll be having around 600 plus images. The images are all everything which I took now only. Okay. Even you can able to try, even if you're having vegetables or fruits, anything, you can take some samples and name the corresponding class, then click train over here. So this is purely based on the internet connectivity. Okay, based on the internet connectivity only it will work. Okay, so from my perspective, yeah, 1 minute. Yeah, it is getting trained. Okay, so I felt suddenly it's got stuck. So based on the internet connectivity, it will work. Okay, so already we are having a particular model. Model means the mathematical way of expressing it. Okay, I'm connecting these images to that particular model such a way that I am going to get a new model which is purely based on these data sets. Okay, so these things are all data sets. These things are all data set. Okay, so once this is processed, here it will be output. So this is the data visualization space. Okay, so by basic, okay, I forgot to add the class 6 as a pi. Okay, by basic, it recognizes me as a class 6. By basic, it recognizes me as a class 6. So if I'm taking a board, taking a Freescale board, so once I start showing that Freescale board, it automatically recognizes this is nothing but a Freescale board. If I'm showing Azure board, yeah, it recognizes the Azure board. Even if I'm showing Renaissance board, it detects and it classifies. This works purely based on the CNN. Okay, convolution neural network. This is works purely based on CNN is a scalar way of predicting the image, whereas ANN also we can able to use that's purely for artificial neural network. That's purely based on the vector based one. Okay, so I'll be explaining those things also. Okay, so here MediaTek, and finally I will show the Arduino also. Okay, so if I'm showing this board as like this, still it detects as a class 6. If I'm sure like this, it detects as a MediaTek. The thing is, what I tried means, okay, while I'm taking the image sample, for all the image sample, I took only the board. For the Raspberry Pi, I took my face also. Okay, so whenever my face is detected, it recognizes me as a class 6. I mean, the Raspberry Pi. Okay, so that's what the image recognition is happening. Okay, this is purely based on the shred. Okay, so and this is what the ML demo it is. Okay, so we are having some data samples. Okay, we are training. After that, the output is ready. So even if you want to export this model, you can able to export this model. Okay, the JavaScript, everything is available. You can able to add to your web app or website, whatever you feel comfortable. Okay, in your particular tool. Okay, you can able to add it, integrate it. Okay, everything is free. I mean, everything is available. One and only thing is here we are giving some data samples. Okay, based on the data sample only, this code will work. Okay, so if you are changing the data sample, if you are showing something else, let's say I'm going to show my mobile. Practically, it's hard to identify the mobile. Okay, so practically it won't identify properly. But to have a clear understanding, okay, we should have at least some lakhs and lakhs of samples of data. Then only it gets recognized. Okay, so this is the demo with image processing. Even I'll be showing a demo with audio also. Then I will connect with the actual slide. Okay, what I'm going to present. Okay, so this is for a clear understanding. This demo is for clear understanding about how the ML works. That's it. So I'm going to connect with the audio sample. So here I'm not going to add multiple classes. So I'll be going to record some audios, okay, continuously for 20 seconds. Now I'm going to repeat some words continuously for 20 seconds. Okay, you can hear. Hi, 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 hi. Yeah, I recorded those samples and I'm going to extract those samples. So now these things are a data set. Now I'm going to add two more samples. Hello, 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 hello. Except finally I'm in the third class. Okay. How are you? 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 Yeah. So I connected with the different samples. So I'm going to train this model. So the same procedure, what I did for the image, so I'm doing for the audio also. So it's getting trained. Okay, after it's getting trained, after it's trained, okay, we'll be having a clear model. So by basic, it identifies under which category it is. So if I say hi, 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 so you can able to see everything is in the class one. If I say hello, 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 hello. So these things are all under the class 2. Okay. So how are you? 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 So now this falls under the class. The same methodologies. What happened? Okay, the similar methodologies. So I'm using over here also. Okay, so here also it works fine. Okay, continuously it takes the sample, the audio sample. Based on the audio sample, it classifies. So here we are having only few samples. Okay, so if we are having more than 1,000 samples or more than some lakhs of samples, our accuracy will be bit different. Okay, so that's what I'm trying to say. Okay, so this is everything is purely based on the accuracy of the data that what we are going to train. So if we are having a more data, our accuracy will be very good. Okay, so I think you got some idea, okay, about what is this. Okay, now I'll be connecting with the actual thought process of how to connect these things. So whenever I'm taking the session, I will always connect with the data which is directly from the Intel. Okay, So even these things are all available for everyone. So by basic, if machine learning is nothing but the process of the machine to accept the data, or the process of the learning mechanism, okay, from the machine. Okay, let's assume we are all the machines, the humans are all machines. Okay, while we are start riding the bicycle, the first time. Okay, we don't know how to ride the bicycle, we don't know the balance, but at the initial stage, we will be focusing on the right hand brake and left hand brake. Okay, and the balancing and hip rotation. Okay, the pedaling for right leg and also for the left leg. Okay, so the concentration, everything we are focusing at the same time. At the initial stage, we are learning. Okay, once it is get practiced again and again and again and again. So now we feel, okay, if we are riding the bicycle now means, okay, we'll be having a headphone, okay, connecting with some music or some other connectivity, and everything, the pedaling, everything works in a subconscious mind. Okay, at the initial stage, if you are having a more data, if you are practicing with those data, so we are all in the position to accept everything. Okay, so once it is accepted, then that's nothing but a model for that particular data set. Okay, once I am comfortable with the bicycle now, because the thing is, what I'm trying to say is, once I comfortable with the bicycle, okay, I know how to ride the bicycle. Okay, this machine, I am the machine, knows how to ride the bicycle. If you are not connecting with the bicycle, okay, you don't know how to work with the bicycle for those particular data. Okay, each and everyone is machines. Even deep learning, AI, everything works based on the neural networks. Okay, if you are comparing the humanity, the humans and the machines, your understanding will be a bit different. Because if you are going somewhere, okay, suddenly if something is happened, some accident is happening, or someone is insulting you, okay, you are not shouting and you are coming out and you are doing. So these things are all method of adaptive learning mechanism. Okay, so even Professor Vijayendra Babu said that after 2020, what are the technology is thing. So by 2025, okay, so the advanced topic like DL, ML, these things are all fundamentals in 2025. Okay, so in future, it's purely based on the adaptive learning mechanism. Okay, even I can give a different ideology of what is reinforcement learning. Let's assume you are not going to, I mean, I'm giving a work, but you are not doing that work. But if I'm forcefully giving the work to you and you are doing that work, okay, so this process is nothing but a reinforcement learning. Okay, so likewise we can connect those ideology in the normal humanity. So in this machine learning, the time series analysis is one. Okay. So time series analysis is one which we need to focus. Even I will be explaining about the time series analysis also. So this is nothing but an ideology of a machine learning. What's the machine learning is? The machine learns something. If machines infer something from the data, okay, no need to program anything. Okay, the program which is nothing but we will be having some mathematical way. Okay, based on the data set, we will be having some mathematical way. Okay, so that we need to focus. Once it is trained, now a new model is created. Okay, so in ML there will be different types. Okay, one is supervised and another one is unsupervised. Okay, so here it shows the data points have known outcome. Okay, similarly I will be explaining you. Okay, if I'm going to explain about the supervised learning mechanism. Okay, so let us assume, okay, I'm going to get a mark. Okay, after +2, okay, I got some X mark. Okay, So whether I'll get see it in AVIT or not. Okay. So let's say for this logic, if I'm taking a individual sample, I can able to say, yeah, you can able to get the seat. Okay. So if around 2 lakhs people are all available, 2 lakhs data set are available. Okay. For the entire data set, it's hard to calculate it. Okay. For that, we are having a mechanism called supervised learning mechanism. Okay. So if you are taking a single sample, you can be able to connect clearly. But if you are taking huge number of samples, it's hard to connect. Okay. So here, that's what I'm saying. The data points have known outcome. Okay. So for unsupervised, okay, yeah, we don't know the initial point, we don't know the final point, we don't know anything, but we need to do some mechanism to learn. Okay. So that's nothing but the data points have unknown outcome. Okay. So even if you are going for a retail industry, as if you are running a retail industry, okay, a particular product is selling, the product X is selling a lot. Okay. But you don't know how this product X is selling a lot. Okay. Under which category? So once you are start categorizing it, what are the age groups is buying? So what are the age group is coming under which season? So everything you need to focus. Then only you can able to identify what it is. These things are all comes under unsupervised learning. Okay. So I'm not going in depth. Okay. So if you are in the position to identify, if you are in the position to understand this slide, I'm sure that this is more than enough for you to understand ML and DL concepts. Okay. So just now I shown a demo with image processing, the data with answers. So I connected with the different classes, the Azure, Freescale, everything. Okay. So we'll be having a mathematical model. We'll be having a mathematical model. We connected to the mathematical model also. Okay. Once the labeled data set or the data with answers are connected to the mathematical model, now a new model is created. So after the fit, only a new model is created. Before the fit, in the program, it has some mathematical way. That's it. Okay, but it's not connecting with any data. So after the fit, this model is capable to connect with this data set. Okay, if you are showing some other data set, it won't work. Okay, this model is connected with this data set based on the mathematical computation from here. Okay, so now if I'm giving some other data without answer, connecting to the model, okay, it predicts under which category it is. Okay, so this is the methodology that we are adopting in most of the MLDL cases. It's not most, in all the cases. Okay, if you are in the position to understand this slide, I'm sure that you are very, you feel comfortable with the ideology or concepts of ML. That's it. Okay, so here the labeled data. So just now we seen the different things, labeled data and connecting to the model, and I'm going to fit. Once it is fit, the model is ready, and if I'm connecting with any other unlabeled data, this model connects and it predicts and it defines the label under which label it is. So it connects with the corresponding category. So I think you got some idea about what is ML it is. Okay, if you are having a doubt, okay, you can able to chat in parallel. Okay, I can able to explain you out. Okay, so now I just explained about. Okay, Vamsi. Yes, Vamsi. You can unmute and ask the doubt, please. Yeah, Vamsi, you raised the hand. If you're having doubt, please. Okay. Or if you are not in the position to unmute, and then you can able to chat also. Okay. So I can able to help you out. So these things are all ML. Okay, so I'm not going in depth of the ML latest. Okay, so practically we can do in within 1 or 1.5 hour session. Okay, so now I'll be connecting with what is DL it is. Previously I gave an example that how to ride the bicycle, the understanding of concept of how to ride the bicycle. So this is nothing but a ML. So if I'm let's assume you know how to ride the bicycle. So suddenly I'm taking you with the bicycle in the highway, any national highway. Okay, so you feel a bit difficult to ride it the initial stage because the pattern is entirely different. While you are riding in nearby home, okay, that's different from while you are riding in highway. Okay, so in this case, okay, the same data but in a different position and different way, then also you have to do the riding and you have to accept it, you have to do it. So that's a DL concept. So that's nothing but a deep planning. Okay, by basic. Okay, here I can show some the network structures. Okay, so network structures. So here the light blue are all input and dark blue are output layers. Okay, so in between some orange color layers are there. Okay, these things are all hidden layers. These things are all hidden layers. Each and everything is nothing but a neurons. Okay. Okay. Each and everything is a neuron. So let's assume I'm going to give my hand to Dr. Hema. Okay, madam, I'm going to use your name. Okay, sorry. Okay.
Yes, sir. Yes, sir.
So I'm going to give my hand to Dr. Hema. From Hema's perspective, okay, I'm giving hand. Let's us Mohana that I am giving my hand to Dr. Hema. The Hema is giving the hand to me. So she can able to see, okay, the input layer, I'm giving my hand, and she can able to see the output layer. She gave the hand to me. So the input is I gave the hand to Dr. Hema and Hema gave the hand to me. So we did the handshake. So this is what we did it, but from Dr. Mona perspective, okay, she can able to infer the input layer and the output layer. She can't able to identify the hidden layers also. Okay, let's assume if Emma madam is closed her eye, I'm giving my hand, practically she don't know. Even the input is not fed. Okay, so she can give the output. Okay, so let's say she is opening the eye. Okay, again I'm giving with connecting with a different scenario. Let's assume eye looks bit dirty. Practically she may give or she may not give. If she knows me well, she may give. Again, if I got affected with COVID-19, I'm sure that she won't give. She should not give. Okay, so if I looks dirty, if I looks connecting with COVID-19, okay, if I'm thief, she won't give. So she is connecting with the different thought process in her mind. Okay, practically everything happens in the subconscious mind. Everything happens in the subconscious mind. She calculates with the many things. Then only, if everything is, then only he is rotating his hand and he is giving giving her hand to me. Okay, so then only we can able to see the output. Even these hidden layers happens in her brain in a subconsciously. Okay, so the thought process of understanding DL is each and every ML connecting together, we can say this is nothing but a DL. Okay, each and every layer is having some mathematical capability. Each and every neuron having some mathematical capability. Okay, so it has to identify, the data should be trained. Then only the input and output will be giving the maximum accuracy. Okay, let's assume Dr. Hema never seen me. If I'm going in front of her home and I'm giving my hand, practically she won't give. She will ask, "Who are you?" Practically she will ask. So the thing is, everything is based on the data that what we infer. Okay, and the hidden layer is processing. The output is reacting. Okay, so here you might have seen the demo. The input we gave already, we gave the input. Here I'm showing it's a hidden layer. So it's not a hidden layer. Already some is there. This is nothing but a trained with this data. Then if I'm giving the any samples, it defines as nothing but output. Okay, the image and also audio, you might have seen it. So this is the process of a DL and connecting through the neural network structure. Okay, so if you are riding a bicycle, I mean, if you are riding any bike, okay, assume you are a rash driver, okay, you are taking suddenly at the right direction and taking the left direction, everything is suddenly, but practically your neural network is working with a high quality. Your neural network has multiple hidden layers, so you are in the position to take the decision, okay, within some fraction of seconds. Okay, that much of decision making algorithm is happening in your brain. I mean, those things are all nothing but neurons in the brain. Okay, so the same thing what happening in our brain, the same thing we have to incorporate into the original mechanism in artificial way. Okay, so that's what we are saying. This is nothing but a each and neural network structure. So the same thing what happened in the human brain, we need to incorporate the same thing into the machines. Okay, so now I'm taking a sample of a neuron. I'm going to take a sample of neuron. Okay, so this is the neuron. There will be a multiple input from the previous layer. The previous layer can be some other hidden layer or can be some input. The output after the neuron, the output is fed to some other hidden layer or to the output also. Okay, output from this neuron, not the entire output. Okay, so the data from the previous layer, yeah, this is the transformation, the mathematical mechanism. After the mathematical mechanism, how the output will be, the particular neuron output. Okay, so let's assume if I'm considering the input as a x1, x2, x3, the corresponding weightage is w1, w2, w3. The practically the input is x1, w1 plus x2, w2 plus x3, w3. Since we are connecting, if we are doing the mathematical process, we'll be adding some bias, I mean some error. So I'm going to add some error also. So practically the input is x1, w1 plus x2, w2 plus x3, w3 plus b. Okay, so that's what I'm mentioning here, like z equal to x1 w1 plus x2 w2 x3 w3 plus b. Okay, the input is fed. Okay, so some mathematical calculation will be there. So if the input is z, okay, connecting to the function f, the output will be f of z. Don't consider this is a z transform. This is not a z transform. Okay, if I'm naming input as a m, output will be f of m. Input as x, output will be f of x. Okay, after the function, what will be the output? Okay, so that's what here I mentioned it. Okay, the input is z, output will be f of z. Okay, so I'm writing in a mathematical way. So if we are in the position to identify the different algo, okay, then we'll be having a different mathematical mechanisms also. Okay, so here I'm just giving an idea or the conceptual way of the importance of the mathematics in a DL. Okay, without mathematics we can't do anything. So I'm just explaining the importance of the mathematical character. That's it. Okay, so this is nothing but a DL. So previously I just explained you about the ideology of what is ML it is. Now I'm adding some more masalas such a way that this is nothing but a DL. Okay, so I'll be connecting with one more algo. Okay, I'll be connecting with let's assume I connect with the CNN algorithm. I'm not going in depth of the CNN algorithm. I'm just giving an ideology of how the CNN works. Okay. So, okay. By basic, if you are taking an image will be separated into different pixels. Okay. So, if I ask you, okay, how the pixel is connected. Okay, each and every pixel there will be a number. That number relates to the color. Okay, combination of multiple pixels. Okay, we can able to see a image. So if we are having a more pixel, we can connect that image quality is very good. Okay, and connecting to the different colors. So here I'm having 3x3 images. This is the image. This is the kernel, or we can say this is nothing but a filter. Filter also we can say. Okay, so I'm going to connect the scalar unit. Okay, so I'm taking this one over the input. Okay, I'm going to connect. Okay, so like this. Okay, so I'm placing over that. Okay, then I'm multiplying 3 into -1, 2 into 0, plus 1 into 1, plus 1 into -2, plus 2 into 0. So connecting, and I'll be getting only one output like this. Okay, so this is nothing but a filtration process. Okay, so in this image, okay, here I'm having only 3x3 images. So if you are having a very big image, like 1000x1000 also you can able to choose. Okay, in a square images, okay, in a square matrix. Okay, so the output we can able to calculate as output as, let's assume this is m cross m, this is n cross n. The output will be m minus n plus 1. Okay, 3 minus 3 plus 1. The output will be this one. Okay, so this how we can able to connect the output. But here this image is something like a we are, let's assume we are connecting to the we are having an image, we are connecting to the shred vertically. So we'll take the odd number together and even number together, and again we do the shred process. Okay, horizontally we can take the odd number together, even number together. So finally we can have different images. Okay, everything looks like the same. This is purely useful for the classification algorithm. Okay, classification mechanism. Okay, so we can have a different way of connecting the kernel. Okay, here we need to connect with the maximum data set. Here I shown only 3x3. If you are considering the image, it will be having some 1000x1000 also will be there. So we need to identify the corresponding kernel. Okay, based on the data set, then only it will work. So we should not put the randomly like -1, -2, -1. Okay, we need to work with the mathematical way such a way that we need to identify the proper kernel. Okay, or if you don't know the proper kernel, we will be utilizing the existing algorithm. Okay, existing mechanism, how it will work. So the research in the CNN is purely based on the kernel only. Okay, so here likewise, let's assume this is 5x5 images. I'm placing the kernel, and again I'm placing somewhere, again I'm placing somewhere. So finally the output is 5x5. This is 5 minus 3 plus 1 is nothing but a 3. So this is the output. Okay, like this. Yeah, I'll show you a GIF image also. Yeah, I think you can able to see it. This is not an exact image, but somehow like this. Or even I can show some other GIF image also, like this. Okay. So till now I just shown without padding. Okay, so without padding, okay, the padding mechanism is nothing but, so if I'm considering this age, okay, we will be having the datas. Okay, if I'm considering 1 2 0 1 0 0 2 1 2, so connecting with the kernel. So I can able to connect this as a midpoint. So I can able to get this piece only, this piece only. So practically I can't connect with the edges. So for that, we are adding a padding mechanism. We are introducing one more row, one more column. I mean, two row, two columns. Okay. The column at the left and the column at the right, and also row at the top and row at the bottom also, like this. Okay. So we are adding those things. Then we can able to connect the edges also, and we can have the corresponding output. So here, once I added the two rows and two columns, so this is nothing but a 7 cross 7. Okay, so 7 minus 3 plus 1 is practically 5. So the output will be 5 cross 5. This is how the CNN mathematics will work. Okay, this is purely a scalar unit. Okay, even if I'm connecting CNN, that's purely a vector unit. Okay, so I'm just explaining the ideology of how to do with the padding also. Okay, everything is a theoretical way. Okay, so I think you got some idea about what is ML and what is DL. Now I'll be explaining you with the time series analysis. Share some ideology of the time series analysis. So if I'm explaining about the time series analysis, okay, I'll be using a generic example, okay, because this is the easiest way to explain. So I'll be drawing something over here. And so here you can see. So here you can able to see some boxes. So let's assume this is lane 1. These things are on road, lane 2, lane 3. So we are having 3 different lanes. Let's assume. Okay. So and I'm going to connect. Okay. Here we are having a car. And also we are having one more car. And also we are having let's assume this is a dark green, red and light green. Okay. By basic, okay, I mean I'm giving a scenario. This light green car should overtake the red car. So by basic, if I'm connecting, okay, so here there will be a disturbance. Okay, there will be a block. So we won't, by basic, if you are focusing the rule, we have to overtake by right direction. But by logic, here we will be having at the left direction also. So here we will be moving like this. Okay. So how we are doing, how the time series analysis works. So that's what I'm going to explain it to you now. Let's assume. So this is the distance that you need to cross. This is the distance that you need to cross, but like this. So now here, this is the theoretical way, this is the practical way, but here we can able to see a distance. So if I'm connecting, I can able to get some triangle shape like this. I can able to get some triangle shape like this. So once I got some triangle shape, okay, here I'm having some degree of rotation. Okay, some theta. Okay, so practically this might be around, let's assume, here I'm going to take the left direction of 30 degree. Okay, once you took the left direction of 30 degree, after that, once your car reached this position, you need to bend 30 degree to the right also. You took 30 degree to the left over here, you need to bend 30 degree to the right also. Okay, so what I'm trying to say means This is the actual way, but here you need to take the 30 degree to the right, such a way that then only you can able to connect with the straight line. So practically we won't, so this is a theoretical way. Practically we won't do like this. So by generic, we will be doing like this. Like this means so we'll be taking around 40 degree. Okay, let's assume we'll be taking around 40 degree. So after this position is reached, okay, I mean this position, it takes 1 degree to the right, 1 degree to the right, and gradually for around 40 times, then only it reaches the position. Okay, so likewise also you will work. Okay, so for this, okay, what I am trying to say is from here to here, based on the time, we can identify the degree of rotation to the left and also the degree of rotation to the right. Okay, and from here to here also, okay. Similarly, we will be having different points. So practically, we will overtake this car in 10 seconds, but we'll be having more than thousands and thousands of datas. Okay, more than 1,000 datas, okay, that we are connecting based on the position with respective time. So that's what I'm saying. The time series, I mean, if I'm connecting the autonomous car, the time series analysis is more important. The machine automatically should take the left direction and then should take the overtake and should take the straight line. So these things should be done, but okay, this works purely based on the time series analysis. Okay. Without the time series analysis, this won't work. So that's what I'm trying to explain. Okay, the time series analysis is more important, not only in this. If you are working with the share market, the time series analysis is important. Okay, so the data connectivity, which is based on the time. Okay, so the time series analysis is more important. So here how important the time series analysis it is. But even I'll show. So in time series analysis, you can say the different methodology. Okay, so one is a trend. I mean, practically the time series analysis. Okay, I'll show this better. Okay, with the three different components. One is a trend, another one is a seasonality, the other is a residual. Okay, so how the trend will be? I mean, even you can have a you know what are the different hashtag is connecting. That's a purely trend, but the climatic condition is a seasonality. This is a purely periodical behavior, and the randomness is a residual. Okay, so if I'm connecting with the different way, I can able to identify the different time series components. Okay, so with this time series component, I can able to connect with. I mean, if I'm taking some fraction of seconds, then I can able to connect. I can able to connect the autonomous car. Okay, if I'm focusing on a large gap, okay, I can able to connect with the share market. Okay, so everything is to forecasting the future. That's it, nothing else. So today I'm purchasing some shares in a particular price. So tomorrow how it will be? If I know those details, then I can able to connect those things. So these things are all applicable with the time series components. Okay. So if you are having time, please spend your time in the time series analysis also. Okay, you can able to get the clear ideology of how the time series analysis works. Okay, even I can show something like this. So we can't show the real-time data now because since today the market is on leave due to Guru Nanak birthday. So I'm not explaining the share market. I'm just explaining the time series analysis. I'm just explaining the time series analysis. Everything is works based on the time series analysis. Okay, how it works. So even I can able to connect with the day-wise chart, week-wise chart. Okay, here we can able to see the different pattern. Okay, once we started to see the different pattern. Okay, so I can able to visualize it. So here suddenly it's increased, and why it is increased? We need to focus. Then practically we can able to follow based on those thought process. So market trend is to once it is increased, it has to go down. If it is down, it has to go up. So that's the logic for most of the market. Okay, so once it is increased, it will go down. Okay, so here we can connect with the different pattern, like a triangle pattern, different pattern. I'm not explaining these things. So that it's not only the autonomous car in a financial, in agriculture, in a different domain. Okay, in cinema industry, everywhere, media industry, everywhere, the time series analysis is too important. Okay, so you can able to connect with those time series analysis. And also, I just want to show one more link. Intel space, machine learning space 101. If you are typing these things, you can able to get link like this. Okay, so if you want to learn something, okay, from the machine learning, okay, so not only due to COVID, okay, the Intel is providing this platform for free of cost for past many years. Okay, here if you want to learn about the machine learning, okay, so they provided this link: deep learning, AI, NLP, time series analysis, deep learning for robotics, anomaly detection, FPGA. Okay, connecting with the deep learning, everything is Intel is provided. The one and only thing is you need to open and you have to spend the time and you have to work. So here they provided with the 12 weeks of structure. They are not providing any video courses. Okay, so these things are all, I'm just saying these things are all standards. Okay, so if you are learning the standards connecting with the Intel platform, I'm sure that you are great. So to work on the platform, you can use colab.research.google.com. Okay, this is the Colab environment. Okay, collaboratory environment directly from the Google. Okay, you can use. So let's say I'm just opening some sample. So all the data is ready. Okay, so this is I just work for some other medical image processing. So everything is available for free of cost. Okay, if you are having a Gmail, you can able to utilize this. So this is the purely a Jupyter notebook. Okay, connecting with CPU, GPU, and TPU. Okay, if you want to change into GPU, so you can able to connect in the network setting, change to GPU. None is nothing but a CPU. Then it's a GPU, then it's a TPU. TPU is nothing but a transfer processing unit. GPU is nothing but a graphical processing unit. Again, based on the data set, and if you are having a huge data set, you can able to connect with the TPU. If you are having a huge data set with the vector based one, then you can able to connect with the TPU, connecting with the TensorFlow. Okay, you can connect like anything. The one and only thing is what I'm trying to say is, okay, machine learning, deep learning is a must to have in future. Okay, but under which application you are going to work? So for this, you should know the time series analysis. Okay, if you are in the position to understand the time series analysis, I'm sure that you feel more comfortable. So for this, Intel is providing the core structure. Okay, Google is providing the environment. The one and only thing is we need to use those standards such that we know how to. We should know how to connect with the MLDL, all these things. So these are the opportunities. These are the ideologies that I'm trying to say. Okay. So if you are having a doubt, you can ask. Okay, so if I know those answers, it's good. If I don't know, I will say I don't know, and I'll share a mail. Okay, within 1 or 2 days. Okay, if I don't know the questions from your side, I mean answers for the questions from your side. Okay, so I think if you're having doubt, you can able to ask. So I just explained this what is ML, what is DL, and I just give them the basic idea, nothing else. If you're having doubt, please ask. I can able to respond to you. I want to. I mean, I just took only 1 hour. Okay. Okay. So I thought it should not be a board session. Okay. If you're having doubt, please ask.
Thank you, sir. Student, do you have any doubt? Kindly ask now itself. Sir will answer. And one more thing I need to share with you all. With this, the students can use the facility of internship. Already we have discussed with sir. So the candidates, those who are interested, virtually you can have the internship with this Raspro Pro, and virtually you will be provided with a platform to work, and you can learn. And in future, based on your performance, for your job opportunities too. So it is a very good opportunity which is given to you from the speakers. So sir has has already informed us. So the students are ready, means based on your interest, he can give you the internship, and in virtual mode you can learn more. So those who are interested, you can give your names to us, and we can carry out, and we will discuss further. Those who are interested, kindly come and meet us and give your names for future endeavors. Thank you, sir. Uh,
Yes. Yes.
Karthikeyan, sir.
Yes, ma'am.
Now I request Professor Karthikeyan, Assistant Professor of EC Department, to give vote of thanks.
Okay, thank you, ma'am. Good morning, everyone. I feel honored and privileged to get the opportunity to give a vote of thanks for this workshop. Right. I thank our magnanimous management for their support in conducting events like this. And then I thank all the vice principal and principal for their support and the guidance extended towards organizing the event like this. Right. Especially I thank Dr. D. Vijayendra Babu sir, Vice Principal Part-Time Studies, for his continuous guidance and support in all the activities which we are doing. And I thank our HOD, Dr. L.K. Hema ma'am, for her support towards all the activities of the department. And most importantly, I thank our chief guest, Mr. Sabarinath Perumal, founder CEO, Respro Labs Chennai, for delivering the workshop on machine learning and deep learning. Sir, thank you, sir. It was enlightened sessions. Right, we'll be looking forward to a detailed and elaborate session from your side in future, and guidance for our students also. Right, I thank the organizers. I thank the organizing committee members of the department of this event for organizing this wonderful event. I thank all the faculty members and colleagues for their support and organizing this event. And last but not the least, I thank all the students and the participants, those who are participated in the workshop. Um, Thank you all for your participation. I expect all your active participation in the future events also. Thank you. Thank you, one and all.
Thank you, Karthikeyan, sir. Now I request all the participants to give the feedback which is given in the chat. So kindly all of you fill the feedback, and I request all of you to switch on your videos for a virtual photo. So kindly switch on your videos.
Hello. Am I audible?
Yes, ma'am.
Thank you. Thank you all. So I request all of you to fill the feedback form. I request all the participants to fill the feedback form. Thank you very much, sir. It was really a enlightening session, and we are looking more forward from our student to use these facilities that sir is ready to give you a virtual internship. So develop your knowledge and work virtually. And those who are interested, kindly share your names to your faculty advisors. In future, we will have some internships. Thank you, sir. Thank you very much. HOD ma'am,
Yes,
could
yes.
we finish,
So
ma'am?
on behalf of our institution, I am formally saying my thanks to today's speaker, Shri Shabarinath Premlal sir. So the session was very lively. So you have shown two use cases, and you have highlighted the importance of this time series analysis also, and how this machine learning and deep learning has having more impact on various domains also you have highlighted. So this is a very lively session, I have to say. Formally, we are closing this event. Thank you, one and all, join.
Yeah,
So,
even I'd like to thank you and the management and especially the patients from the participants. Okay, thank you all, thank you all.
Thank you, sir.
thank you, sir. Participants, kindly fill the feedback form